I'm going to attempt to show you that the quotient rule just might be a waste of your memorization skills because it's basically the same thing as the product rule in disguise. It uses the chain rule to kind of prove this, and so that's what I'm going to do to prove this to you. So what's the chain rule? Well, the chain rule is, let's just say we had a function called h of x, and let's say that function was 1 over another function called g of x, right? Well, that's the same thing as g of x all raised to the negative 1 power, right? And the chain rule says, okay, well, what's the derivative of that? What is the derivative of this guy, right? What is that? Well, that says, the chain rule says that you take the exponent and you bring it to the front just like before, so it becomes negative, the negative of that g of x, right? Then you decrease the exponent by 1, right? This is the normal power rule, what you do. You know, you've seen that before. And then here's the interesting part. You multiply, you look at the inside and you multiply by the derivative of the inside, right? The derivative of g of x is just g prime of x in this case. So this is what the chain rule is. So let's simplify this a little bit. Okay, and this is basically h prime of x. That's good. That's great. So let's simplify that. So our g of x, our g prime of x, sorry, is going to go on top, right? That's going to be our numerator, and this is going to be a denominator because it's a negative exponent, right? So we have basically g prime of x over g of x squared, and the whole thing is negative. All right, and that's h prime of x. Okay, so that's what the derivative of g of x in the denominator would become. All right, that's important to know. That's basically what the chain rule tells us. Now, what's the product rule? The product rule says, okay, well, what if I want to find the derivative of a function when it's being multiplied by another function? You know, what is that? Well, the product rule tells us it's the derivative of the first times the second plus the derivative of the second times the first. Okay, pretty straightforward, no big deal. Okay, but what if we have a function that looks like this, f of x over g of x, right? And we want to find the derivative of that. What do we do? Well, isn't that the same thing as the derivative of f of x times 1 over g of x, right? This would be our first function. This would be our first factor of the product rule, and this would be our second. And isn't that the same thing as the derivative of our function times our second function raised to the negative 1 power? Well, yeah, of course it is. So how do we find the derivative of this? Well, using the product rule, you know, if we call this a and we call this b, it's the a prime times b plus b prime times a. And a prime, I'll pick a different color here. A prime is just f prime of x. And b is just what it is right there. It's just b. It's g of x to the negative 1, or f prime of x over g of x. Okay? And then we have a, I'll write the b prime part first. So it's this thing, the derivative of that. Well, we already found that up here. Right here. That's the derivative of g of x to the negative 1. So it's basically the derivative of g of x over g of x squared, and the whole thing's negative. So if the whole thing's negative, it's going to be a negative exponent. A negative sign right there, okay? So it's the derivative, right, over the bottom squared, right? All right, well, and then it's also, so now that's b prime, and we multiply that by a. So that's multiplied by a. Okay, great. Now this, I'm going to try to combine these two fractions. How do I do that? It's not that hard. I multiply the top and the bottom by g of x. And what am I left with? I'm left with f prime of x times g of x over g of x times g of x, or g of x squared, right, minus g prime of x times f of x over g of x squared. And now I can combine these two functions. They have a like denominator. So let's do that. Then we're going to get f prime of x times g of x minus g prime of x times f of x over g of x squared. And that is the same thing as the quotient rule that you saw. So just using the product